Oh boy, here we are. Welcome back. How you doing? Getting ready for another stream this week. That's our Discord. Hacker man. Div. Gotta love it. And we're gonna continue working on the adventure engine, turning into something like an interactive fiction engine. Not really sure where we're going with this project, other than we're just gonna like keep it going a little bit, because I think there's gonna be some fun things to learn. Yeah. One of those fun things I think is going to be coming up. I've been discussing on Twitter with some folks and things like that. There's a pretty major refactor of the engine internals. One of the things we do a lot in here, there's a big pattern, is this code's relying a lot on monad fail. And that's fine. I don't think there's really particularly anything wrong with it, but I'm not super experienced in such matters. I don't know what the current argument is, but it came up that, like, you know, maybe monad fail should be something to discourage or get rid of or something. I don't know. Sometimes I find in communities of really smart people, you get some very opinionated folks. And so, anyway, we got to discussing it, and I think I agree that, you know, this code is just getting a little bit, you know, up there. And there's enough verbiage going on, enough of a pattern going on here that we could really take advantage of a better structure for the code. Like monad fail is just causing a bit of noise, extraneous noise for the most part. So we might get to that and create ourselves a little monad type structure for our game engine. For now, it's just all functions, plain old functions. It's pretty straightforward. Some stuff happening in either again, like that. So before it gets too unwieldy, we might want to do that. But I think first we've got some things to wrap up, gameplay-wise, perhaps, that we want to add before moving on to that. That's just like a code cleanliness thing. It's not really going to affect the gameplay of the game and how fun it is, right? So, all sorts of things I find tend to get, you know, put on the back burner if you try to make it a thing. Like if you're on your job, it's like somebody's like, hey, we should refactor this. I don't, there's very few organizations I found that will sit down and say, yes, we agree. Stop doing what you're doing and just noodle around with the code to make it nicer to work with. Some places probably do that, but I haven't been in one of those teams yet. So what I usually recommend is that you kind of refactor as you go. Let's say like, well, in order to introduce this change, I need to do a refactor here to make the change easier to introduce. You just kind of do it. And Haskell really facilitates that, which is a nice thing, I think. And one of those things that I've always kind of really wanted to show on the stream, because like a lot of people talked about it on paper. You know, Haskell's really good at helping you refactor stuff mercilessly. We've done it a little bit here and there in parts of different projects. But that's going to be a pretty big one. So let's look at our to-do list here. We've got item to item and item to room interactions we wanted to be able to do. I actually don't have huge plans on those right now, to be honest. So with all this talk of the refactoring, I think I just want to get into it. And then maybe like kind of let that stew a little bit. Item to item interactions, what that should do. I guess the idea with item-to-item interactions is that we want to be able to, like, use an item or combine items. Something. I'm not really sure. Let's write down a couple of those ideas, though. Maybe combine items. Some ideas. Yeah, so we're just gonna chill and we're gonna try and refactor this tonight. That's what we're gonna do. Okay. So the big thing when I do refactorings is to work in small steps and to always get back to a compiling program as quick as you can. You don't want to leave it hanging for a long time because you can get lost in the weeds. So we have the file watcher on, always compiling. We don't have a ton of tests on this project, but if you're like more of a test-driven situation, those are also good to be running while you're doing the refactor. It's just so that you know that if you've moved code around, you haven't changed the behavior of the overall system. Or get early warnings if you have. Is one way to look at it as well. So yeah, we don't want the type checker to stay red for too long. And what too long is going to be fuzzy and kind of like change depending on the project and the size and scope of the refactor that you're doing. But I find what I end up doing is that if I go too long on something and it's not getting anywhere, I'm not making progress, I'll tend to just like throw out that commit, that code and start again. Just be like, ah. So what I'm going to do first is, let's see, we're on master. That's probably fine. Let's stay on master. It's all good. We just want to commit in small chunks as well so that we can like back out of stuff pretty quick. What I'm going to do, I think I'm going to, so what I really want to do with this engine, the pattern I want to do is I want to have like proper, like not proper, but like I want some notion of exception handling in this code and not rely on the implicit behavior of monad fail, which is what we're doing here in either, for example. Like we're going to get an object in the inventory, and because we're using the binding here, we're actually implicitly relying on monad fail. So like if this returns a left, it's going to like bubble up somewhere. Okay. And we kind of do this pattern a lot. There and there. And we have these other functions up here sorry, a little further up, that deal with like manipulating parts of the state or the world. Like, I don't know, where are they? Handle walk, handle verb, handle look, pick up, blah, blah, blah. I was thinking of the, item object, yeah, so like current room, exit current room, get object in room, update current room, get object in inventory, so on and so forth. And so we have this concept of like state, and we have the concept of potentially throwing some kind of game error, living in kind of separate worlds from each other. Just, again, fine. It's one way to go about it. It's not entirely wrong, but I think we can kind of bring this together a little bit better with that. So what I'm going to do is I'm going to look for the main entry point in the game engine that the other parts of the code use. And I'm going to just wrap that in the monad I want, which is still an accept like thing. And in fact, this is kind of a vestige here of the text-based REPL that we used to have in this game engine. Where we have like an accept T here and a new type wrapper. So we're going to do that again because we're not doing that anymore, but it's going to be like an accept T over state T kind of thing. Right. And I'm going to basically just wrap the main entry point function in something like that. And give it that type. And then I'm going to start slowly lifting parts of that into that code. So the main entry point for the engine, the GUI is really what's controlling the main thread of execution here. Start is what main calls. Gets the initial game state and calls start app. And start app comes from Monomer. Well, we define it, but it hooks into Monomer, which runs the main thread and sets up things like the graphical context for the UI and kicks up the event handling and all that sort of stuff. And the UI calls into the engine in a couple of ways. We handle these game events, app input received. Right, we call this update game function on the model. And the model here is the game state. Right, and the other place that we do, I think the rest just reads from it. Oh no, the other one is the, let's see, update and quit. Exit application. Yeah, this is the main place where it talks to the game engine. The other place where I was thinking of was the, app input updated. So we update the input buffer in the game state there. Right, so this is just getting text from the text input widget and updating the buffer that we have there. And then when we have the app input received event from the key press, the enter key press, then we call the update game function. It's the update game function. Let's look for that one. It's kind of our main one here. Yeah. Game state to game state. All right, no mention of anything here that could go wrong, right? We case handle everything here internally. If we get some error, update the game errors with left, with the right world. Otherwise, we render it rendered and so on and so forth. Yeah. So this is probably where we can run the game engine. Now this is going to be a bit of a speculative change because, you know, as I'm reading this, I'm like, this isn't like so bad, really. But I'm just told that monad error. Yeah. Let's look up why. Why is monad error bad? Well, we got why is monad error helpful? This is more of a different language, Scala thing. Maybe this is the one. All those are just talking about the specifics of a particular Monad errors. Sorry, I was talking about monad fail, not monad error. Monad fail. Ah, there we go. I think this is the part of the discussion. So a couple of years ago, we proposed to make applicative a superclass of monad, which successfully killed the single most ugly thing in Haskell. GHC 710. Now it's time to tackle the other major issue with monad, fail being a part of it. Okay. We're going to learn something here. Currently, this symbol, I call it bind, I don't know why, but that symbol is unconditionally desugared as follows. Something must fail. Computation, da-da-da. The problem with that is that fail cannot be sensibly implemented for many monads. For example, state, IO, and reader. Okay. In those cases, it defaults to error, which goes to IO unconditionally. So as a consequence, in current Haskell, you cannot use monad polymorphic code safely, because although it claims to work for all monads, it might just crash on you. This kind of implicit non-totality baked into the class is terrible. Okay. The goal of this proposal is adding the fail only when necessary and reflecting that in the type signature of the do block so that it can be used safely, and more importantly, is guaranteed not to be used if the type signature does not say so. So to fix this, they want to introduce a new type class. Desugaring can now be changed to produce this constraint when necessary. For this, we have to decide when a pattern match cannot fail, so on and so forth. Okay. So this seems like one of the more principled things. Those sort of principled kind of changes you get in a language where something's kind of ugly, or someone thinks something is kind of ugly, and proposes a change to make it better. This happens a lot over the years, of course, in a lot of different language communities. JavaScript, C++, I can imagine a few in there. Some of them are good, some of them not so good. This one might be pretty good. At least they're not going to like fully take away the pattern. They're just going to like change the syntax a little bit, which is kind of annoying. So I wonder how people are taking this then. This is going to require code changes, isn't it? It's adapting old code. Yeah. So write some code to make it work. Change your pattern to be irrefutable. Emulate the old failure by desugaring the pattern match by hand. So like change your code. This doesn't usually go over very well. However, they are taking some foresight to look into this, which is a good sign. All right, so using our initial implementation, we compiled stackage nightly and grepped the logs for the warnings, assuming the implementation is correct. The number of missing monad fail warnings is 487. Okay, that's cool. So when we do this refactor in this code base here, for this code, we're basically just going to be better citizens and make our code a little bit more extensible. Because if we use like the stack pattern, the monad transformer pattern for stacking monads, like the original monad did, then we can add things like, I don't know, stuff, logging and things like that. And we're going to eventually have some other like more IO interacting things that we might want to interface for like things like saving and loading game state. So not it's not a refactor in that this code needs it because it's super bad and this is just difficult to extend, but more in the future us will thank us kind of way. So without further ado, how do we want to do this? We can either run our monad inside of update game, because update game has this really nice signature that's like just game state to game state that the GUI kind of uses. And that would keep us from having to like do anything over here. So I think that's good. We should probably keep that type signature for sure. And we'll just change this block here. So how are we going to do that? Well, that means we're going to need like some kind of function here instead of like case matching directly on handle prime. It's probably part of it. Look at the type signature of handle prime. Yeah, this is what we need to, where we can make our incision point here. All right, so handle prime is just returning the either back, which is case matching in there, right? Instead, we can change the type here. Either t. Here, some m, and returns a new world as a result. And that won't be either t. That should be ft. I don't know which one is better. We saw that blog post where somebody was going to duke it out about which one was not good. Monad fail, monad either, or except, monad throw. The other thing that is good and like there's trade-offs in all software design, of course. It's a very pithy aphorism, but monads, when you're considering going down this route that we're going to go and like running stacks, pretty common pattern in Haskell. So like I don't think anybody's going to get super mad at you for choosing to go down this route. There's a lot of like weird like difficulties with and weird things about how they combine, because they don't combine as nicely as functions, pure functions do. They combine in very particular ways, and depending on the implementation, things can sometimes leak or not work so well. So maybe we should pay attention to this. Problem with using monad throw, this is from 2019, so not too long ago, should be still relevant-ish, is that the caller can theoretically expect just about any exceptions to be thrown, whereas with monad error, the now small range of errors that the caller can expect to handle is known at the type level. Yeah, monad error, E, sounds pretty good. And mirrors what we've been using with either a little bit closely too, so the change should be a lot easier to make, I think. So monad error might be the one, unless someone really says this is not a good idea. Okay, yeah, okay. We're gonna try monad error. That seems reasonable. I think that comes from control .monad.accept. Okay, we already have that. Okay, and it's already defined on that new type, yeah. So, yeah, we already have it in scope. So we go accept T, game error, some M, and returning world, right? We have to, that M has to have some constraint on it. So we're going to get some type errors right away, of course. We're going to go right into the red here. And a bunch of red places. This is a good thing. And what I really like about working with Haskell code is that, like, I change a type like that, I change an object, and there's like, boom, here's all of the exact places where your code is now currently broken. So now the name of the game is to get this back to going green again with our change intact. Cool. So, next step. We've made it accept T game error, blah, blah, blah. And pretty sure we have to put a constraint on M in the type here just to say that this is a monad. Not something weird. Cool. So we've got a few type errors we got to fix now. First on 298. Let's jump over to that one. Here. Okay, immediately, first something.parse input. It goes to a tuple. First, right, parse returns text to either game error verb thing. Right, and interesting. We're going to try and make this code here work. This will be a lot easier for our types are in line here, but once again. Okay. All right, so one thing we can do is we can just turn that function into an accept T as well, and that should make the types line up. All right, now it's going to make us chase down, let's see, 298 there. Oh, I changed the wrong thing. I changed initial game state. Oops. Doop. Really me. Tricks are for kids. Here's that back. Bad. This one is the one I wanted. T, game error. M. And so I don't know if I'm going to do a good job of explaining monad transformers, but if you haven't encountered them before, general idea, I guess, that I would explain them as is like, you know, I use function composition a lot on this stream, right? Where you kind of like use the dot and you kind of compose two functions together, f with g. And you get a new function, right? Because everything's curried, so all functions take one argument. Right? And if you understand that, then The next thing is that we're going to want to compose other things, not just functions, like monads. You can say, why can't monads compose? Should they be able to be composed straightforwardly? And they don't, unfortunately. Not as generally or easily as functions do. They can, but in very particular ways. And so, really, really smart, fun people. Hackers, really. True. All kinds of folks came together and discovered this kind of pattern. First monads, and then how to like make different monads work together, like either and maybe and so on and so forth. And kind of stack their functionality together. So that's the common, I think, analogy, I guess. And people call them monad transformer stacks. Right? It's, if you think of this as like this M here is a monad's like in the middle, it's underneath the except T. And we could stack another monad on top of this except T, maybe, hypothetically, some other T. Here, that returns some value on the outside. And so on and so forth, right? And we can build up a stack. I'm not going to do that, but we're just doing one level here. And at the bottom of the stack, this M at the bottom of the stack is always going to be like IO or something like that. Usually, I think IO is usually at the bottom of the stack. But this lets you lift effects up the stack as well. So if you think about the stack, you can always lift something up from the bottom, but you can't reach from the top down. So the order in which you compose these matters, right? And yeah, and then of course some of the tricky things we've seen with desugaring and stuff are fun, and you know, the kinds of monads you choose depends on like their abstractions and whether they are leaky abstractions or not, whether they play together well with other monads. Really depends on a lot of things. So it's a pretty unusual pattern, I would say, if you're coming from software development from a different programming language. But once you get to that level in Haskell where you're comfortable with, or comfortable-ish, you don't even have to like be an expert at it, but once you're comfortable-ish with transformers, you can get a lot done, for the most part. And then you get to a point where you're like, wow, I kind of wish I had this in other programming languages, even though it's not like perfect in Haskell. There's a lot of arguments and criticisms to be had, but the cool thing I like about it is the structure it gives you. That's what I like. Okie dokie. So in our, I think, parse command here now, in parse we have an except t now, and it's calling a function that also returns either. So we could turn that into an except t as well and continue on the trend. And that's really parse command's fault here. Right, parse command is going to take a list of text, return an either gamer or verb, list of text as a type. I think that's the type, yeah. So we're going to turn that into except t. And that's going to be a monad as well. I don't know if the monad precondition is always strictly necessary. Right, that could still be pure, but now, instead of like returning left, we get something a little bit more semantically meaningful about what we're actually doing, right? Look at this handy dandy function. I think it's throw error. Is what is defined for acceptee, if I'm not mistaken. I might get a type error here, but I think that's what it's called there. Yeah. So whereas before we were returning left, this kind of very generic type, right? And we're using it a particular way. And kind of by convention saying left means error, right? We're transforming this code a little bit in this refactor, and now because we're using acceptee, we're actually like saying, okay, throw an error. And that's a little bit more meaningful, right? So like semantics, meanings, what does it mean to return left? Well, when it's very generic like that and you just return left, you have to kind of know the convention and the language of the program you're looking at. The language is in like the conventions and the context of what you're reading. Whereas throw error is much more specific, has a very direct meaning. It's not very generic and like, I don't know, it could be, left could be anything. Left doesn't mean anything, really, at all. Itself, the name itself is a convention, right? So we're adding a little bit more of specifics, I guess, by doing it this way. And that's nice. So let's continue on with this and getting rid of these type errors, getting back to green as quick as we can here. So I'm dawdling and rambling a little bit because I'm trying to explain things as I go along, but usually this goes quite a bit faster. So we got 300. Let's jump over there. So first here as well, same diff. We're calling get verb. Notice we don't actually have to call, we don't actually have to throw an error up here for it anymore. The appropriate error gets thrown further down. So get rid of that. Just call get verb. All right, what's get verb going to do? Probably going to give us a type error and tell us we got to change a function to acceptee, right? Yeah. There's another one. So let's go to get verb. It's going to be a lot of these, but we're going to handle them one at a time because why rush? Best just to let the type checker guide us. We'll eventually knock down this list. We'll get smaller and smaller and smaller until we're back to green again. And we've known as along the way that we're only making tiny small changes, just changing the types of things to get them to compile again. We're not trying to change behavior or anything else like that. Okay. So small, tiny steps. 275 is the next one we're going to look at. Boom. Our get verb itself is using maybe to write to convert a maybe to an error thing. When we go to do the lookup, we don't really need to do that. Now we can do the lookup and we can throw. But we need a new combinator here. Was this one we wrote here in this code base? I think that might come from here, yeah. All right, so something similar, just not maybe to write anymore. We need maybe to throw. And now we're going to turn accept T, B, M, and returning A. Very, very generic. Combinators tend to be that way. You don't tend to talk about the specifics of the types you're getting, which is why they're so polymorphic and so bloody useful. All right, so very similar code. So here we're just going to return pure X. And in the error case of nothing, we're just going to row error. apply. So we can jump back to get verb. And change that to maybe throw. And that should handle that. Let's see. 301. Handle verb. This is going to be the more complicated one, probably. It does a lot of work with either here. And we'll just change the type, and we'll work through it. Fortunately, we came up with command hand deliver as a type alias, which we can allows us to change this all of these little handler functions in one place, because they're all going to need to be the same thing. Hopefully we can put constraints on that, no problem. Pretty sure we can. Okay. Either T, that's silly, except T is what I meant. Cool. Yeah, so that's gonna... Type aliases are sometimes useful, sometimes not. This idea, this constraint here can't be on it, because I don't know how to explain it properly. But it doesn't have like a, what do you call it, like a quantification question mark? Yeah, anyways, it's not really like a kind of like a definition. So there's no M in scope here, so it can't be polymorphic, basically. It's, I guess, a terrible way of explaining it, but that's the general gist of it. We can't have this M here in a type alias. So, what are we going to do? I think, wonder if we can move it down here, and by replacement and reasons, that will just be happy. No, it won't, because it doesn't have a definition. Okay. No longer useful. So what are we going to do about that? That's kind of a stumbling block here. I was hoping that was going to be useful, but not because of that. Well, we could make type a full-fledged type. We can make it a new type, just over this function. And that would let us have M. Try that. Command handler. We're going to do this silly. We're going to do the first thing that comes, the simplest thing that comes to mind that could reasonably work. All right. Now get command can have an M in there. It's an actual definition of a type. It's not an alias. This is going to mess things up a little bit. Because we're going to have to add that constructor in to all of these places. Like that. And then we will want to get the function out to actually apply it. to its arguments, we're going to have to also, similarly, call get command in order to get that function out and apply it. So, not a huge change, but it should let us do this. Throw error. Let's do that. And now now we're gonna have to go through each handler here and fix all of these up. So let's do that. Let's see, is that the most recent build error there that we got? Oh, it is still actually a problem here. Oh, weird. Okay, we're gonna have to put... Oh, we're gonna have to put it in the type definition on the left-hand side, aren't we? Oh, that's an illegally qualified type. Da, 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 da. Technically not allowed unless you have that extension enabled. Because get command is like a function so that's a higher rank function there. Which is why you need the rank n extension, rank n types. Yeah, I got rid of it. I moved it out. I don't know why the builder is not seeing that change anymore. There we go. Cool. So now command handler is going to require that argument. In all of them. Yeah. Okay, well, we can probably do that one in a quick kind of sweeping motion, because it's fairly mechanical. So we'll just do our place. Add arrow command handler and then we should get back down to business. Oh, we forgot one place. And this is why you want to be able to take the ability to back out of. We probably should have done a checkpoint before we did the new type thing, actually. Because that would have been a good place to kind of go, I'm not sure I like this command handler thing. And back out of it if we needed to. Without ruining the rest of our things. Now we have a big undo tree in the buffer instead of saying that in Git. So, do as I say, not as I do, as they say. That's the gist of it. But these all look like good errors that we want. All right, so like when we run all of these, so this error here, it's just getting command handler M2, but handle walk is applied to 2 arguments, blah, blah, blah. These are all coming from here. Because we now have to unwrap those command handlers to get back to accept T. with get command. Handle walk. I think that'll work. Not quite. Yeah, command handler is none. So what we need to do, not compose it like that. That's for sure. And compose it like that. Or I might be able to compose it like that. No, yeah, we have to do it with the parentheses that way, I think. Oh, this tool, I should fix my tooling setup here. Yes, okay, so that's the way to go. Then handle pickup, WX and all those. Okay. 1, 2, 3, 4. Hit command. Whatever, go to the beginning of the line, go to the next one. There and there, fix you, fix you, fix you. And then instead of left, we can of course replace that with row here. Oh yeah. Okay, and now we are back into here. Okay, so in this type error now we have expected to type of command handler M. That's because we haven't applied all the wrappers and all these handler functions, but I think we have handle walk mostly good where we want it. Except, yeah, we can't take the args on this side now of the equation. We have to take them on this side. Like near. What was I doing? World and args on this side. Because the function's inside the command handler. Handle walk is just the definition of a command handler, so we have to construct it. Okay, so now we're getting kind of a more annoying error of the different numbering of arguments, and that's because we have to change all of the functions to match this new paradigm. Do we like this? Gut check. Do we want to go down this route? No. I don't really see the point of having it as a type, to be honest. This is just more annoying to write. So you know what? Gut check's right. Let's go back. Normally, well, maybe there's a quick way we can back out of this. We haven't done too much damage. We can just undo those hunks. Yeah. So I think what I'd rather do is just copy paste the type, what I was using the type alias for before, copy paste that around. Like, I don't think we get much of an advantage by writing it in a new type. only because we're not going to be really using them as data, passing them around. For the foreseeable future. Like, I can't really imagine why we would want to do that. So, yeah, let's discard that. Get rid of your not handle. We want to keep that one. We'll get rid of the handle pickup. Yep, rid of that one. That one. Get rid of drop. Yep. Examine. Yep. Yep. And dig. Yep. Okay, rekeep maybe throw. That's good. Okay. So we'll just copy paste the type back in. And that's a lot easier to do. Do that. Replace command handler with not that, but this. And while we're at it, we'll change that to accept T. Mirror M world with down at the beginning there. Yeah. That'll be nicer. Cool. Handle verb has a problem on 301 now. Handle prime has a problem because that's still either. So let's change that to accept T. Game error world. There we go. Super duper. Okay. I'm feeling a little better about this way of doing things. We still have a command handler somewhere. Thing on handle lock we missed. Okay. Fix that. Fix you. Okay, we like that. I couldn't know how to do this. No, I probably just forgot. Did we forget? Oh, right. Yeah, forgot that. There we go. Okay. The time for silly type errors is over. Or not. It's not typing yet. Stream brain has struck again. There we go. This is what I'm looking for. Yes, good, good, good. Okay, so these are all type errors because, yeah, these are all the type errors I want. Yep. Good. So let's knock all those out. It's kind of a long list to see there. I really wish this was in line because it would be a lot easier to see what's going on as we're going down this. But I still haven't. Let me see if I can look at that quickly and get that working. One way of doing this, set variable, the Haskell mode that's built into Emacs, process type, I think is the variable. And if we set this to stack GHCI, and it should use the GHCI command from stack, like using the stack command line program if we have that installed, and configure that out. Now, try to load the code for this. It's trying to compile stuff. Oh, it does. Okay, we're good. We're in business. Sweet. If that's all it took this whole time. Oh, that's why I turned it off, because this annoying thing keeps coming up. It's illegal use of lambda case thing, and for some reason, StackGHCI is not very happy with me and my use of extensions. I can't really figure this out. So I'm going to add lambda case here. See if that makes it go away. There we go. Oh, man. Okay, baby. We're in business now. Much better. So we know how to fix this one. Throw error. Next. Jump to next error. We know how to fix this one. It's simple. It's throw error. Ah, so much better. Okay. So this type error. All right, we have exit current room. Exit current rooms on either. Not in accept-T necessarily. So let's jump to exit current room. That wants to be an accept-T. Make a similar transformation one step at a time. Boom. Probably going to get some type errors in here. That current room also wants to be an accept-T, so let's make it. Cool, fetch. Fetch also wants to be an accept-T. Well, so let's make it an accept-T. You're cool, fetch. We like you. I have to put little parentheses around those. Cool. So then current room. What's wrong with current room? Ah, yes. That's because get object in current room is now needs to be an accept-T. So basically blanket. Oh my gosh, this is going to be happening a lot to us. Not a problem. I feel like that's going a little too far over the left, so I'm going to stack these. There. There. Stack them like this. How am I going to stack them? I like the arrows first, generally. Yeah, like this way. That's the way. That's the way I like it. There we go. That's good. Now, I'm not going through these and trying to do giant mass replaces generally, because I find that if I do that and I mess something up with my massive giant find and replace, it's kind of a, it's pretty easy to jump back out of, but it's really hard to figure out like where, at least for me, maybe it's different for you, but it's a little bit difficult to figure out where we went wrong with it. And I just like going one at a time through them. Yes, it's fairly mechanical, somewhat tedious. Some of them could be automated, that would be nice. But it's also just zen-like. So, like, when I'm having a rough day, I'm not having a rough day today, but also if I'm having a rough day when I'm working in Haskell, and something's just like, I'm not getting something, the code's just really hard to follow, sometimes I'll do the refactor like this, and you just kind of follow the motions. How do you change this equation in order to fit types, and how do you do this, and how do you do that? It's all comes together. Almost like programming on autopilot. A little bit. You still have to pay attention, but. Except T, game error M, there. Okay, so we got all of those. Let's jump back to our next error. This one. Maybe to write again. We don't need that anymore. We have maybe throw. For that one. And yeah, we discard the results, so that should be right. Let's go to the next one. Maybe throw, we know how to fix that one. Let's go to the next error. Boom. Okay, move player. That's a locally defined one down here. We helpfully explicitly wrote the typo for. Okay, so we're going to fix this function. We know left, we know how to fix that. That's just throw error. And that makes those type errors go away. Cool. That one's pretty simple to fix. Again? Where? Okay, maybe to right, we know how to fix that. Should be maybe throw now. In fact, we can probably replace all of those in here. No problem without too much fuss. Make those go away. There we go to the next one. Look in container. I have to go into the definition of that one. It's just below that. This needs to be updated to an except T first. Okay, cool. Get object current room, get object, we've fixed all of those. So the only error left inside here is this one. You know how to fix that. Throw error. Cool. And see how we're kind of just progressing slowly through the list, and it's just getting smaller and smaller. Love this. One of the best things about working in Haskell. One of them. Yeah, so these two as well. Maybe throw. What did I do? That one. Maybe throw that one. Know how to fix that. That's a throw error as well. So, chat, maybe you can help me out with this. I got a kind of a talk idea brewing in my head. I don't know how I want to frame it yet, but I'm looking for examples of Haskell code that you might have encountered that was difficult to test. And why is it difficult to test is the important part. I'd like to know why you thought it was difficult to test. I'm looking for more examples to add. Because I find that, with some exceptions, like say this project, where it has some tests, but not that many. I tend to rely on software testing a fair bit. And that's because, especially in larger systems that have like some pretty complex behaviors, types don't always check behaviors. And behaviors also act as kind of like a somewhat informal of specifications, or an informal way of writing a specification of a software system, right? And so the idea that, you know, we shouldn't write tests kind of boggles my mind. Like, well, how do you gauge then your software is doing what you think it ought to be doing? Right? And so I find that there's sometimes some certain patterns in Haskell can lead to code that's difficult to test. Like any other programming language, it's not immune to this difficulty. I'm kind of curious if you've seen any out there that you'd be willing to share with me. Doesn't have to be in the chat now. If you want to bring it up in DMs or something like that, that's cool too. Find me on the Discord if you follow the link above, or follow me on Twitter. At least for now. I'm trying to find ways to get off of Twitter. Mainly because Twitter decided to do some things with their platform and their tech, and as they're allowed to do, that I don't agree with and I don't want to support. But I have a sticky problem in that Twitter is like one of the only social platform I really use other than Twitch here. A little bit on YouTube, but I don't really interact with YouTube all that much other than to like post my videos and like respond to comments on my videos. But I don't usually get too many comments on the videos on YouTube, so I don't really do a whole lot on there. But it is like a primary way. Twitter is kind of a primary way I interact with a lot of folks in the open source community as well. Keep in touch with them. It's not something I can just go cold turkey on without upsetting peeps. Unfortunately, as much as I would like to, but I am looking for alternatives. Maybe we can build something here on the stream. Let's see. We'll have to think about that. Maybe to write, maybe throw. Almost. Update current room. That's also okay. Current room needs fixings. Let's check that one. Well, that one should be an acceptee. What's the problem here? Oh, you're not an acceptee in render. Okay. Of course. Now this is going to mostly work out, it looks like, because we're already kind of balancing everything inside of either. And not doing a whole lot of else with that, so that's kind of nice. The problem with this, get exit. What is the problem with that? Yes. So the type of get exit here, we didn't specify it. Entity ID of exit, probably. And we're already kind of using the pattern just without being explicit about it. So it's all kind of coming together pretty nicely. Let's go return exit. Where? Here. Not having to work too hard for that, which is nice. Okay, so update game now. Okay, now we're back to here, and we're very close to getting back to green now. Right, so handle prime is no longer case matching. This is not returning just a pure value left and right. We actually have to like execute handle update. So when we execute handle update, we can get, let's just bring up the type for that. Actually, maybe it's, maybe it's in scope already. Type of unaccept. That's not in there. It's going to import it. We'll just import it. Control dot accept. Run accept T. Oh. Okay, let's just pull up the webpage for it, because I'm terrible at remembering things like that for some reason. Google. Run accept T. I swear that's what it's called. Oh, it's control.monad.accept. That's what I'm thinking of from MTL. So we don't have that because we're not using MTL? Or I've just not imported the right thing. Okay, I just imported the wrong thing. Control.monad. I do have MTL in this project. .accept. Run accept T. So I wasn't nuts. I just didn't import the right thing. Yeah, that's supposed to be a T, not an R. There we go. There's the type there. Okay, so it kind of lifts out this either EA, which is kind of why I think this transformation worked pretty smoothly into some monad M, or M-like thing. Except it doesn't seem to actually say anything about what M is. But this is the convention. All right, so the idea here is that we can we should be able to bind that value when we run the computation. A lot of these kinds of monad transformers give you some way of doing this kind of thing, where you build up your stack, right? You build up your stack of things in that stack, right? And you kind of give them such a stack and you run it. All right, run accept pulls it right outside of the M. Looks like. We have an accept T here, so I don't know if we can run that one. All right, and so that kind of like peels off a layer. And what the stack analogy comes back to the fore here too, because if this M was, say, another monad underneath, like we had a state monad underneath as the M, that M would now be the outer monad here. Right, so we'd have the state monad with our either EA in there by running accept T. So it kind of like peels off a layer. And then we'd have to run something on that monad to peel out that layer until we get down to the juicy core, right, of what we're looking for here. Okay, so what do we do when we run accept T? We're going to get back M of either EA. Might not be super awesome. Because this is a pure function. There is no M that we're running inside of right now. Yeah. So that's the type. This is the type alias for the acceptee of identity. So there's no, this would be the underlying monad here. It just says it explicitly that it's identity for pure things. Which is pretty good. We could might be able to use that. I have a suspicion we won't be able to do that, but anyhoozle. Run accept. Let's give it a shot. Survey says you can't. Well, you can. We just have a different type error. Okay. Yeah. All right. That works. Fine. Good. Hello. Haskell Cat's here. Yay, Haskell Cat. Hello. So we have to do the same thing for render, because render is also an acceptee that we have to unwrap. So we run that, and then we should be good and back to green. Almost, but not quite. Looks like a very simple thing we forgot here. So let's just go to that. Initial scene. Right, so we're computing the initial game state. Well, we can run accept that render. Let's see here. And the problem here is, well, maybe we just got the type quite a little bit wrong. There we go. And almost there, almost there. What do we miss here? Fetch. What's wrong with fetch? Okay, Haskell Cat, you gotta sit down, hon. What's the matter? Move like this. There we go. Fetch, fetch, fetch. Let's fix fetch. Did we fix fetch? We did fix fetch. Yeah. Let's look at the type error. No instance for monad m from use of fetch. Oh, here. Maybe one more of those, perhaps. Yeah. Okay, and cool. A couple other little small things where it's like, oh, miss them. Miss little things like this. Little redundant do action. Just warnings. Yeah, we're just in warnings now. These, at least. How come you're getting a type error, though? So I'm looking at really old state here. What's going on? GUI's got a problem. Okay, cool. Yeah, this module's green. But it looks like we've introduced some change to the interface that is used by the GUI there. Looks like the GUI is kind of rendered, pulling into our game engine in a weird way, which kind of exposes an interesting problem there. Let's clean up these warnings before moving on. That's that example. That's an accidental shadowing. And then this one as well. Pow, 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 pow. The whole redundant bracket. Okay, cool. And just a couple small things. Let's go. Not use success text. That can't be right. Let's see. Ooh. Yes, it is quite right. We should have success text display. That is a bug. Player has key items. We move the player. And what we really want to do here is update the world state with our log messages with the success text. We don't need to do log for that. We can do it with a pure left binding, I think. World prime. This world where normally I don't like to do bug fixes in the middle of a refactor, but it's such a small one that I'm doing it anyway. Just because we're here. Success text with yeah. Okay, and this one. Just redundant bracket, simple things. Care. Arg's not used in dig. That's not too unusual. What? Oh, just get rid of const and okay, cool, yeah. A nice little transformation, thank you. Yeah, that's probably, this is probably a bug here too, but I'm not going to fix that one. And that's probably, well, not exactly going to fix that one. Or maybe we should, because this is what, I think this is the bug here, is the GUI is reaching to render the player inventory. Looks like, I'm going to come back to that one. Yeah. Update game, we're not using errors. Might be a potential other bug as well. So I'm going to leave that one as well there. And state, that's just a shadowing. Okay. I'm going to leave the other ones, the other warnings in there. When we go hop over the GUI, I think we're going to find a couple of problematic things. One is going to be that's going to be a really annoying thing. I don't want keystroke. This one. Yes. Okay. Where's the error? No, not that. Yeah. Okay, my jump to errors is kind of getting in the way here. This thing here. Right. So the problem with this is that the GUI code is reaching into our game engine interface to pull out data out of the game state directly, which is fine because it's got to be able to get data out of things to render stuff. But we changed the API of get inventory objects is basically the error here. So we're gonna have some issues a couple of issues with that. Render object. Yeah. Yeah, and there's my to-do actually right there. Fix error handling. This is stinky. It sure is. Now we're gonna fix it right now. Okay. I think the way we can do that actually is by fixing try render game object. Type of this currently is, I believe, to be a either game error or a list of game object. I think that's the type. Probably, I'm completely wrong, probably. Actually, we can actually just ask GHC what the type ought to be by giving it a completely incorrect one, of course. Try render game object should be, we weren't too far off. Either whatever, whatever. Game error and object, a list of game object, list of game object. Ugh. Just accept that. I hate putting the language pragmas in here like this. I love putting them in my configuration files. But the HCI is being a pain in the butt. So this here needs to change type. I can actually get it to show up, and it's not going to show it up here. There. That's all keystroke. It's annoying. Oh, anyways. Da-da-da. Right, so this shouldn't be that. I think this should really be like world, or no, game state to accept T, game error, and list of game object. We don't have that in scope. Let's go ahead and add that. One way I'd really like to fix that is to make that exposed without having to know about how to run the game engine's monad. Like the model should just be dumb data. Actually, let's back out of this just a smidge. So we can checkpoint the engine code, because that's like good. save them. Yeah, okay. Stage that. Yes. Okay, commit. Add. Change engine monad to T. Mom, Dad. I'll call it refactor. When applied, this change will refactor engine monad to accept T. Fill that file. Okay. The UI part. Let's reopen GUI. Okay, cool. Still not very useful. Flight check, fortunately. Yeah, so how do we want to handle this part? This should be... We can handle this in the dumb way so that it gets compiling again. I think I want to fix this so that we can just read the inventory objects out of the state and not have to do this lookup logic with this like kind of internal-ish method. But for now, let us do it this way. Render game object. Either, or no, except T, game error, or a list of game objects. That's all this. Game state. Cool. Is that the only place it's used? Yeah, it's a local definition, so nowhere else. It's not just game objects, it's trying to render the game inventory. Player inventory. So we're just gonna move that down and make this model, which is the game state. So we'll call it game. We changed the name of it to render player inventory. So we have to pass in model. Get the world out of the model, we get the inventory objects. That. Actually, we just want to return a list of game object, like in that code. So not even the accept-t. So what we're going to do is we're going to run the accept-t on this function, run accept. We're going to case match on that. So run accept, of left. In case there was an error, getting stuff. What can we do here? Like, we're in IO, we could technically just throw. Shouldn't really happen. But I'm gonna, since I think I'm gonna fix this later, I'm just gonna leave it as like the silliest thing we could do. And write objects, and that's fine. Return the objects. No, no, don't. Whatever you're doing there. That's not what I want. Okay. So we don't have run except because we didn't import it, so let's go make sure we got all that stuff. It's not control.exception necessarily, although something else might be using that. Import control.monad. I think we're back to green. Cool. So let me just put that, well, that to-do is still relevant. But I'm going to update the comment. This really should be moved. There's data. Game state. We want to move it into the game state so that we don't have to do like this run except chicory in the UI. The UI should just read this data as like just data, plain data. Shouldn't have to do any computations to get it. So I'm going to add that to the to-do as well. Don't miss it next time. Yeah, try render later. Okay, cool. That's good there. So let's check it in. Let's just make sure it works, but pretty sure it will. Sorry, C. All right, pick up the shovel. Yes. Dig. Still dig. We have a weird coin. We can drop the shovel. Everything works as before. We try to walk through the front door without the shovel. Still get that it won't budge. We pick up the shovel. We did fix a bug. We walk through the front door now. You should see that. You knock the door with the shovel. We walk out the door. Walk in the door. Oh, we'll see that message every time, which I don't like. However, everything still works as it existed before the refactor. So we're back to green now. The refactor has worked. Yeah. And that's generally how I approach refactorings. Let's commit that as well. Let's just rebase this into 1. Yeah, that's fine. And we'll push it. There you go. Well, it's kind of like not a major refactor in Haskell, but like a pretty big one. So the idea is that you start like kind of at your entry point, you pick your seam where you want to make the change, right? Kind of like the top of it, and then everything underneath it's going to require you to make changes in order to meet the new demand you've made. And so you kind of just go through them one by one, fixing all the types, making them line up, and fixing all the terms at the term level, then making sure that they work and use the new thing. And then once everything type checks again, you want to get back to type checking as quick as possible, right? So you work in small steps, trying to find small seams that you can work in, so you can always get back to green as quick as you can, not lose your place. We got a little bit into the weeds there, but we made it back out, back to green again, and now we're in XFT as our engine monad, and now we can like stack, combine different effects with the engine and kind of rejigger things and move things around to make more sense. So thank you for joining me. It's been nice hanging out with you. This ends the stream for tonight. I gotta run, but I always do these on Tuesday nights at about 10 after 8 in the evenings, in the Eastern Daylight Time or Eastern Standard Time zones. And if you want to get notifications, of course, you can follow me here on Twitch, or if you're following on YouTube, to do there to get notified when I go live or when a new video comes out. And of course, you can join the cool Discord channel for this stream by looking at that link above there and getting on our Discord server, where we can talk about stuff and have live chats and all kinds of fun stuff like that. So thanks again for joining me. May your monads always be free and stack, and may your types always check. Peace out.